All right, so we'll finish with 4 here. All right, like I said, copy that down. Here's where it's a little bit different than yesterday. Let me do it over here. If we had, say, 5 times, and I'm just making this up, 3 to the x plus 4 equals 20. You can divide by 5 because that's a constant. Okay. And then you would just have 3 to the x plus 4 equals 4. And that would make it easier. But this has an exponent on it. And dividing by 5 doesn't necessarily help us because it would just be 6x divided by 5. Either way, we're going to have to deal with a little bit of an issue there. We can't get rid of the 5. So I would keep it right like this. Can't multiply 5 times 4. Really, the only thing you do is take the log of both sides. So I'm going to take the log of both sides as it looks. So that gives me the log of 5 times 4 to the x plus 3. And you can think of that whole thing in parentheses equals the log of 6 to the x power. Now you've got to look and see how do I handle that left-hand side. The right-hand side is really not an issue. Log of 6 to the x will go out in front, we're fine there. But how do we handle that left-hand side? That's really a product. Okay, that's really a product of 5 times 4 to the x plus 3. And when we have a product, how do we split it up? We got to split it up as a sum. So that's going to be the log of 5 plus the log of 4 to the x plus 3. And then I'll move this exponent down on the next step, but that's what it would look like. Make sure that makes sense. So you can have a constant out in front of that 4 to the x plus 3. You take the log of the whole thing, but now you've got to split it up. There's a log of 5 plus the log of 4 to the x plus 3. Now we got to follow our rules for the exponents. The exponents will go out in front. Now this one here, okay, that x plus 3 only applies to log of 4. It will not affect this 5 out in front. So it's just going to be log of 5 plus x plus 3 times log of 4 equals x times log of 6. Now distribute the log of 4, and now we're kind of where we were at yesterday. Okay. So now that gives me the log of 5 plus x times the log of 4 plus 3 times the log of 4 equals x log of 6. All right, how many terms have an x? I got 2 terms with an x. All right, what are you thinking here? I'm just curious. Aaron Hess, what are you thinking?
I'm thinking subtract the x log 4 over to the right side and fill out an x.
Okay, good, because we need to get everything with the x on the same side. That's probably, well, it is the easiest path. So subtract x log of 4, subtract x log of 4. And so I get log of 5 plus 3 log of 4 equals x log of 6 minus x log of 4. All right, and he even said pull out an x because you got both terms have an x in it. That's the only way we can get to this next step where we can divide is factor out an x. So I got log of 5 plus 3 log of 4 equals x parentheses log of 6 minus log of 4. Divide. All right, go ahead and use your calculators and see what you get. Just make sure you don't make an input error. Or 3 decimal places. Okay, good. Josh, what'd you end up with?
14.226.
226. Okay, so 14.226. Now, we talked about yesterday, and I'm not going to put this on the test. I usually do, but we really haven't spent enough time on it. How do you condense that? I want you to condense the top to the log of a single value, and I want you to condense the bottom to the log of a single value. Okay? So just use your rules, and now you got some constants. So condense the top, condense the bottom. If you get a fraction, that's okay. Okay, so you can get a fraction in that case. Now here's what I mean by, well, take a second, see what you come up with. If you're not quite sure, just wait. Olivia, do you understand what I'm asking you to do?
Yeah.
Did you get either the top or the bottom at this point?
I have the top.
What'd you get?
320.
Okay. It should be the log of 320. That's correct. Okay, it should be the log of 320. And then what's the denominator? Log of, well, what's the only thing we need to do with the 6 and the 4? Divide them. 6 divided by 4, that reduces to what? 3 over 2. So now and here's why I like this, is because you type in that whole thing, that's a little bit of a pain, but this is just log of 320 divided by log of 3/2. Okay, you get the same, you have to get the same thing, as long as you do that. Now here's the key, is don't make a mistake going from this to this. If you do, then you're gonna be off. All right, just wanna make sure you understand what I'm doing here. So log of 5 plus 3 log of 4 is the log of 5 plus the log of 4 to the 3rd power, because the 3 goes out in front. 4 to the 3rd power is 64. So that's the log of 5 plus the log of 64. Well, what do we do when we condense it to those two numbers? We multiply them. And 5 times 64 is the log of 320. And then log of 6 minus log of 4, that's going to be the log of 6 divided by 4. Okay, you divide those, and all I'm asking you to do is reduce there. Okay, and that's how you simplify that. That's all you do. You can take that numerator, take it to the log of a single value, might be a fraction, denominator log of a single value. But in the end, negative 14.226, you need to come up with that. Okay. All right, those are exponential equations. The next set deal with logs within the equation. Some of these are really straightforward, and some of those are a little bit messier. But they're clearly different because they have a log in them. We need to figure out the value here. So, all right, log base 3 of x plus 2 equals 3. Log base 3 of x plus 2 equals 3. All right, convert it to exponential form. Okay, so if it's in log form, convert it to exponential form. And so this one here is just going to be your base, which is 3 to this power 3 cubed equals x plus 2. 27 equals x plus 2. Subtract 2, x equals 25. So for that one, that's all you got to do. Okay. Okay, copy down that next one. Now, before you can convert convert it to exponential form, you can't have the two logs there on that left side. So you have to use our properties to condense that. So if you have a sum, what do we do to condense it? We multiply. So now this becomes a log base 3 of x times x minus 2 equals 1. Once you've condensed it to a single log equals a constant, go ahead and convert that to exponential form. So now that becomes 3 to the first power equals x times x minus 2. Now you just need to examine it and figure out, all right, what do I need to do to solve it? 3 to the first is 3. I'm going to distribute my x. Okay, I get x squared minus 2x. So you got a quadratic, you're not going to get rid of it. Set it equal to 0. Subtract 3, I get 0 equals x squared minus 2x minus 3. All right, let's factor it. And x equals 3. X equals negative 1. All right, you need to look at both those answers because one of them we can't use. Look at your original problem and tell me which one can't we use and why. Okay, that's right.
Is it -1?
Yep, it's negative 1, and do you know why?
You can't take the log of a negative number.
And yes, it goes back to this. Can't take the log of a negative number, so you can't assume. So you have to look and say, all right, if I plug a number in, will it give me a negative? Now, sometimes the negative will work because it depends on what the expression is. So if it was like x plus 2, negative 1 would be fine, but automatically right there, it throws it out. Make sure you double check 3 when you plug 3 in, you do get 2 positives. So throw out the negative 1. Make sure you get x equals 3. Can't take the log of a negative. Now I got a minus in between that. Now I got a minus. So log base 2 of x plus 7 minus log base 2 of x minus 7 equals 3. All right, when you got a minus, you don't multiply. Remember what we do? We divide. All right, so do that step and then just think about where you're going. All right, so this becomes log base 2 of x plus 7 over x minus 7 equals 3. Okay, you have it as a single log. We convert to exponential form. 2 to the third power equals x plus 7 over x minus 7. Now, this does not end up being the same type of problem as the other one. The other one ended up being a quadratic. This one doesn't. So you got to be careful you don't assume that they're all going to end up the same. 2 cubed is 8. X plus 7 over x minus 7. All right, what do you think about solving that one? Luke, what do you think?
I'm not sure.
Well, you got that AP shirt on. You got to know. Okay, Josh.
You multiply both sides by x minus 7.
Get rid of that x minus 7. Get rid of the denominator. So we're not going to end up with like a quadratic. Okay, so we got to get all the x's. First of all, get them anything out of the denominator. So I will multiply by x minus 7, which gives me 8x minus 56 equals x plus 7. Now, just solve it. Subtract x. And I get 7x minus 56 equals 7. Add 56. Did I do that right? Yeah, I think so. So I get 7x equals 63. And what do I get? X equals 9? All right, will it work? Does it give me any negatives? No, I think we're okay. So x equals 9. You only end up with one option. Okay, the other one we had 2 there. So in each case, we had one term with a constant. You want to get all the logs on one side equals the constant. Okay, all the logs on one side equals the constant. Now we're going to deal with problems with logs on both sides. And it's just a common sense property, but if you got two logs equal each other, that means that whatever we're taking the log of has to equal each other. M equals N. I think that's, like I said, that's like a common sense one. Don't overthink that. All right, take a look at that first one. And again, don't overthink this one. Don't make an easy problem hard. If you got the log of something equals the log of something, you just set those two parts equal to each other. And you're just going to start with x minus 3 equals 12. X equals 15. Now, they're not all that easy. You wouldn't want them to be all that easy. All right, so we got x equals 15. All right, copy that one down. Before you can set them equal to each other, make sure it's just the log. So this 2 you got to be careful of. You cannot set 4 equal to x plus 3. We got to move the 2 up as an exponent. So it's going to be log base 4 of 4 squared equals log base 4 of x plus 3. Now 4 squared is going to be 16. And then I just end up with 16 equals x plus 3. Subtract 3. X equals 13. And then double check it. You don't get any negatives. All right, now those only had 2 terms. Okay, last one here that we're going to look at. This one is going to be a little bit nastier. All right, log of 7. Now, and you need to look at each term. Each term has log base 7. Like in the previous set, you had one term that was just a constant. So it's a little bit different how you handle those problems. Here, I got a plus. I got to make it a single log equals a single log. If you got a plus, remember that's going to give you a product. So it's log base 7 of 3x times 2x minus 1 equals a log base 7, 16x minus 10. All right, see what you come up with? You're going to have to factor. And then double check and make sure if you get that far that nothing gives us a negative. Right. See what you come up with.
Now I'm just taking that, equal that. Yeah.
Start off back. Back.
Figure out which, how do you figure out which wrong?
Okay. So I'll show that. All right.
Yeah, now you take that, so let's do that. Yep, so you're
At the end of this course, you still know how to factor, that's a good thing. Okay, that should be, now that's not like, that should be like a big. So really, you're gonna set this before that. So it should just be, 16x minus 10 equals that, with no second. Alright, we get. Alright, good. What is it, 2/3 and 5/2?
Yes.
Is that correct? Do they both work?
Yep.
So at this point, I take 3x times 2x minus 1 equals 16x minus 10. Distribute the 3x. 6x squared minus 3x equals 16x minus 10. You're going to end up with a quadratic. Okay, you're not going to, the x squared is not going to go away. Subtract 16x, add 10, 6x squared minus 19x plus 10 equals 0. I'm going to factor this into 3x and 2x. That's going to be my first instinct. It doesn't guarantee it's right because it could be a 6 and a 1, but that's usually the first instinct. What signs do we have to have, though? They both have to be negative. They both have to be negative because I got to multiply to get a positive and yet add to get a negative in the middle. All right, for 10, it's either 1 and 10 or 2 and 5. Well, I'm going to go with my instincts, which are 2 and 5. Those are the first two numbers that pop in my head for 10. Doesn't mean they're always right. But if I pick 2 and 5, I can't use 2 here, right? Because that gives me I can't put the 2 here and the 5 here because I got a GCF and I don't have a GCF in the original one. So I know that takes that option out. So I'm going to try, whoops, that was just what I had. So I'm going to put the 2 here and the 5 here, and then let's see if it's right. And I'm just going to kind of mentally check it. 3 times negative 5 is negative 15. Negative 2 times 2 is negative 4, negative 19. And so I get 3x minus 2 equals 0. 2x minus 5 equals 0. 2/3. 5/2. Cooper, do they both work?
I thought so.
You thought so?
Yeah.
Give me a yes or a no.
Yes.
Of course, they both work. Yep, you plug them both in, you don't get any negative numbers. So we get two answers. Bonus. 2/3, 5/2. Okay. All right, so with this section, you have the equations where the exponents have the variables in them, you got to take the log. And then these have logs within them. You either have log on both sides, or every term has a log, or you have a constant, and then you convert to exponential form. Okay, if you have any questions from the homework, I'll come by and see if I can clean them up. Okay, take a look at these here, or actually do these here. And then we'll review Monday. And then test on Tuesday, Wednesday. No calculator will be Tuesday. It'll be a little bit longer than it won't